Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin Ismail bin Ismail, and today I will present to my panel my final year project proposal, which is the title is Study of Airflow in Model Room with Upstream Object. Before we start, I would like to mention that this title is a new title that have changed from the previous one. And for information, my supervisor is Puan Nur Melissa binti Ali. We will start with our proposal presentation with project summary. The objective of this project is to investigate and study the airflow in model room with the presence of nearby buildings with different size and distance. The method to achieve the objective of this project is to use any engineering simulation commercial tools. The fluid analysis of model room will be tested with different size and distance of upstream object to provide the optimal airflow for the room's thermal comfort. Next, we will go to natural ventilation. What is natural ventilation? Natural ventilation is a method in which the interior air of an enclosed area is continually replenished by fresh outside air through openings for improved thermal comfort and indoor air quality without the need of forced flow. Natural ventilation can reduce the reliance on air conditioning system, resulting in lower energy usage and greenhouse gas emissions. And lastly, naturally ventilated buildings have a greater thermal comfort range than those in enclosed interior areas with mechanical ventilation and air conditioning systems. Next, we will go through the effect of lack of ventilation. The effect is the first one is dampness. Next, excessive pollution, overheating, unpleasant smells, and suffocation. Okay, we will go through a literature review, which is the first one is CFD modeling. Computational fluid dynamic, which is CFD, is a powerful technique and tool for forecasting different flow fields. It has been used to investigate particle scattering and space scattering using various particle evolution models. Next, we will go through upstream object. The effect of nearby buildings has lately been recognized as a critical factor in forecasting the ventilation rate of building in modern cities. The effect of the surrounding buildings, known as the sheltering effect, was studied using CFD features. This is because the rate of natural ventilation is unpredictable owing to the significant effect of building characteristics. For number 3, we have wind-induced natural ventilation. Natural ventilation can be further classified according to the mechanism. The driving force for wind-driven mechanism is pressure difference, and as the pressure difference increases, the rate of airflow increase, and airflow rate is also depending upon the area of opening. Natural ventilation caused by the wind is a passive way of enhancing the interior atmosphere and occupant comfort. And lastly, for literature review, we'll go to thermal comfort. Building use significant amount of energy with mechanical air conditioning system accounting for a large proportion of the total energy consumed. Previous study has shown that the thermal comfort range of occupant in naturally ventilated building is wider than that of occupant in enclosed interior space with mechanical ventilation and air conditioning system. We will continue the presentation with problem statement. The first one is the effect of nearby buildings has lately been recognized as the critical influence on the ventilation rate when estimating the airflow of a building and room. The second problem statement is the influence of the size and distance of neighboring buildings on the ventilated flow will be examined in order to reduce cost and offer maximum thermal comfort in the building. For objectives, the first one is to study the effect of upstream object with different distance and size to ventilation rate in model room. The second objective is to study and examine the airflow inside the model room. Next, we will go to scope of work and limitation. The main objective of this research is to quantify the ventilation rate in the cross-ventilation model and comprehend the airflow impact of the surrounding building. There are 4 cases of objects with different size and distance to be tested and investigated using CFD analysis. The size of the upstream object will be the same as the model room in the first case, and the distance to the model room will be 4 meters. In the second case, the upstream object will be larger and at the same distance as in the first. The size of the upstream object and the model room will be the same in the third case, but the distance between them will be reduced to 2 meters. For the final case, the size of upstream object will be increased to match the dimension of case number 2 with a gap of 2 meters between them. The wind flow will be subjected to 1.8 meter per second and 3 meter per second speed for every condition. We will continue on methodology. Our first task is to create a design of model room with different size and distance of upstream object in CATIA. The second task is to import geometry model of CATIA into ANSYS. And third one is conduct grid independent test in ANSYS. Next, we will do a setup the simulation case using ANSYS feature to obtain the objective. Next, observe the data outcome of the simulation that has been carried out. And lastly, we'll go to result validation. We will go to geometry model. The geometry model will be searched in previous article and journal to get a suitable dimension for model room. The model room will be created with dimension of 0.8 meter length, 0.4 meter wide width, and 0.4 meter height with 2 inlets and outlet opening windows. The windows dimension are 0.12 meter multiply 0.12 meter at the center plane of the wall and will not exceed 10% of the wall's area. The upstream object dimension will be same with the size of model room for the first case study. As you can see in this figure, these are the dimension for model room, upstream object, and we have created a enclosure for this model room and upstream object at the outside, which is called a rectangular domain. Note that the velocity inlet are at x-axis, where the airflow are going through the starter of wall of rectangular domain and flow through a room. Next, we will go to turbulence model, which is the model that we use for this CFD study. K epsilon is implemented and selected. K epsilon model is selected because it is applicable to free shear layer flows with a slight pressure gradient, and it also applicable to confined flows. For computational fluid dynamics, CFD, the objective of this study is to investigate the influence of upstream object of various distance and size on the airflow inside the model room using CFD features. This is the specification data that we set up in the ANSYS feature, which is the velocity inlet is 3 meter per second. The outlet of rectangular domain will be 0 kilopascal. The turbulence intensity is 5%. The gravity is 9.81 meter per second square. Number of iteration is, we use 400 for number of iteration. The density of air will be 1.225 kilogram per meter cube. And building and domain wall, we set the building and domain wall with no slip. Okay, we will go to preliminary result. Before starting the real CFD simulation, the grid independent test must be complete to determine which number of elements will produce the most accurate to the experimental result. As you can see in the table, these are the case that we use to investigate, which are coarse, medium, and fine. The element for fine is the greatest and has been chosen to conduct this investigation. Next, we will go to method of computational. The ANSYS fluent results are validated by comparing them to the published paper. Before we can receive the ANSYS result, we must go through a few stages of method of computational. The procedure is, the first one is geometry. By using fluid flow fluent in ANSYS, the model geometry of the building is imported into ANSYS in IGS format from CATIA. Next, we will do a meshing process. By using Fluent as solver, reference, and linear element order, the size of resolution we use is 5. Next is the setup for investigation. The model is set to K epsilon with the material is air for fluid. The airflow of 3.0 meter per second are set at the inlet for the enclosure, and the end of enclosure are set by pressure 0 kilopascal. Then after the setup, we will run the calculation and get the result. The contour and streamline were created through the Upstream Object and model room. The contour are set to show the airflow in the result. Okay, these are the results from chart line in ANSYS. The first one is the contour result obtained, and the second one is the streamline result obtained. And lastly, we will go to expected result. The airflow and velocity inside the room will next be simulated using CFD with various building size and distance from the room. The presence of air, flow, and velocity both within and outside the structure must be determined. The optimum design of upstream object with the maximum velocity airflow will be identified at the conclusion of this research to fulfill thermal comfort. And lastly, the velocity chart will then constructed by 3 components, which are velocity against the X, Y, and Z axis. These are the results. The first one is velocity against Z. The second one is velocity against X, and lastly, velocity against Y. That's all from me. Thank you.